Chapter 2, Kinematics, Part 1. Okay, I have shifted the last part of Chapter 1, which is about scalar and vector quantities, into Chapter 2 because I think it ties in more like nicely with Chapter 2, Kinematics. Under Kinematics, we will be studying about how do we use physics to describe motion. And then for the first part, we will be covering what are scalar quantities, what are vector quantities, and the terms that we commonly use in kinematics to describe motion, which are distance, displacement, speed, velocity, and acceleration. So these are the learning outcomes. Okay, in the previous chapter, we have learned that physical quantities are any quantities that can be measured. It has a numerical magnitude and a unit. Okay, besides base quantities and derived quantities, physical quantities can be further classified into two categories, which is scalar quantities and vector quantities. Scalar quantities are physical quantities that has only magnitude. Okay, the direction doesn't matter. But for vector quantity, it has both magnitude and direction. So the direction plays a very important role for vector quantities. Okay, in this chapter, we will be covering the difference between distance, displacement, speed, velocity, and acceleration, while the rest of the other quantities you will learn later on in other chapters. But for now, you have to memorize what are scalar quantities and what are vector quantities. So this table must memorize. Okay, and let me just give you a very common example. For example, comparing time and force. Time is a scalar quantity. For time, there is no direction. So we say that, oh, it takes 10 seconds or 10 minutes to move from here to there. Okay, the direction doesn't matter. There is like no 10 minutes to the left, 10 minutes to the right. But for vector quantities like forces, the direction does matter. It doesn't make sense if you say, oh, I apply a force of 10 newtons to the object. So where does the object move? There is insufficient data because force is a vector diagram, is a vector quantity. So if I say I apply a force of 10 newtons to the object, it doesn't tell me where the object moved because I did not state the direction. So whenever you give vector quantities, you need to state the direction. For example, I apply a force of 10 newtons to the right, then obviously the object will move to the right. Okay, so for vector quantities, direction plays a very important role. So we move on into our terms that we are going to use. The first term is the difference between distance and displacement. So if you take a look at this diagram, distance is the total length covered by a moving object, regardless of the direction of motion. I do not care how many circles I make in between. Okay, it's the total length that the object covers. So for example, you take that I have an object moving from A to B. If I were to move along the green path over here, the total distance that I covered will be 10 kilometers. That will be the distance. And if I move along the blue path, I would have covered a total length of 7 kilometers. So that will be my distance traveled. It depends on the path that I take. Okay, but if I were to say displacement, okay, it's the distance measured in a straight line in a specific direction, or the distance traveled in a specific direction. Or in layman terms, it simply means I only care about the distance between the starting point to the ending point. I do not care about how it moves in between. Whether it takes a green path or the blue path, the distance between the starting point A to the ending point B is only 5 kilometers. That's the difference between distance and displacement. So distance can be 10, 7, but displacement is strictly only starting point to ending point, which is 5 kilometers, regardless of which path that I take. I take the green path or the blue path, the displacement is the same, it's only 5 kilometers. Okay, let's take a look at the other example. You may pause the video for a short while to think about it. Okay, I'm going to go through now. So you take a look at this. They ask what is the distance traveled from A to F. Okay, and each box measure 1 meter by 1 meter. So A to F, the distance is the total length covered by an object, irregardless of the direction. So if I were to move from A to F, I will have covered 1 meter. Okay, I will move 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, 6 meter, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so the total distance that the car moved from A to F would have been 21 meters. But if I were interested in the displacement, okay, for displacement, I only care about the starting point to the ending point. The starting point is A and my ending point is F. So I would only care about this distance from A to F, regardless of how it moves. I don't care whether it moves to B, to C, to D, to E, and then finally to F. I only care starting to ending point, which is actually 1 meters, 2 meters, 3 meters. It is only 3 meters, and because it's a displacement, I need to state the direction to make sense of it, okay, because it's a vector quantity. So it's actually just 3 meters due south of A. Okay, and just to take note, scalar quantities have no negative values, okay, but for vector quantities there is negative value. So there is positive and negative for displacement, but there is no negative for distance. So why is there a positive and negative? Because direction plays a very important role. So if I were to take moving in one direction as positive, when my object moves in the opposite direction, then it will be taken as the negative value. Okay, so positive and negative are just assigned for convenience. So you can take a look at this example. If I have a car moving from A to B, and I take it as going to the right as positive, and it has traveled 5 kilometers, I say that distance traveled is 5 kilometers, displacement is plus 5 kilometers. And then after that, my car moved back from B to A. Okay, in this case, let me just jot down over here the distance that I have covered from A to B. Okay, from A to B. Okay, the distance that I have covered would have been 5 plus 5 because there is no negative. I travel 5 kilometers forward to the right and 5 kilometers backwards. So the total distance I have covered is 10 kilometers. But the displacement, there will be negative value once it is moving in the opposite direction. So for displacement, I will have traveled 5 kilometers to my right from A to B, and then plus when I move from B back to A, I'm moving in the opposite direction. So opposite direction becomes negative. So I will have covered another negative 5 kilometers. So my displacement is from the starting to the ending. I start from A, I end at A. My displacement is actually 0 kilometers. Okay, but now let me add on. So I move from A to B and then to C again. So C now is opposite direction from the starting point. Okay, it's moving to the left. So if I were to use my formulas again, just jot down over here. Okay, so my distance covered from A to C. Okay, my distance covered would have been 5 plus 5 plus another 2 kilometers. I don't care, it's moving backwards. Okay, because for distance, the direction doesn't matter. So I would have covered 12 kilometers. But for my displacement, okay, I would have covered 5 plus minus 5 plus now minus 2 because it's also moving to the left in the opposite direction. So I would have covered minus 2 kilometers. Okay, that's my displacement from my starting point to my ending point is minus 2 kilometers. Okay, and if I don't like the minus 2 sign, I can also state the direction is 2 kilometers due west of A. It's fine as well. Okay, so another example to sum up. Okay, so if I have a car moving from A to B and then to C, okay, the total distance covered will have been 10 plus another 2, which is 12 meters here. But if I were to say displacement, I only care about starting point to ending point, which is 8 meters only. Or if you want to use mathematical, it's 10 meters plus minus 2. Minus 2 because it's moving in the opposite direction. So 10 plus minus 2, you get 8 meters. So that is the displacement. Okay, so let's do a table to sum out the difference between the distance and displacement. Distance is the total length covered by an object, irrespective of the direction. Okay, but displacement is the distance traveled only in a particular direction. For distance, it's a scalar. The direction of movement doesn't affect anything, so there is no negative distance. But for displacement, it's a vector quantity, so the direction matters. When I move in the opposite direction, it becomes a negative displacement. For both distance and displacement, the SI units is in meters. So how do I describe distance? It's just 10 meters without a direction. But when I want to describe displacement, it will be 10 meters to the right. Okay, the direction must be stated. Okay, next you can scan this QR code and then try the wizard level. Okay, to learn more about distance versus displacement. Next, okay, we move on into the next terms that we are going to use, which is speed and velocity. So what exactly is speed? Speed is a measure of how fast the object moves. Okay, there is a formula for it. If you still can recall from primary school, okay, which is DST. Okay, so speed is actually distance over time. Okay, so speed is defined as distance traveled per unit time. Okay, the divide it actually means per unit time. Okay, divide means per unit. Per unit means in layman terms, and in formula it means divide distance divided by time is per unit time. Or I can also write it as speed is rate of change of distance. Okay, rate of change is also the same meaning as divided by time. Okay, it has the same meaning as divided by time in words, which means the rate of change. Okay, and then the SI unit, distance is in meters, time is in seconds, so the SI unit for speed will be meters per second. Okay, then other than speed, sometimes the question might not ask you to calculate the speed, but they ask you to calculate the average speed. So just take note that average speed is different from speed. Average speed is the total distance divided by total time taken. It has the same SI units, meters per second. Okay, and next we have something called instantaneous speed, which is the speed at a particular instant. Where can we find instantaneous speed? We use a speedometer to measure it. So in vehicles, there is always a speedometer. When you step on the accelerator, you will see that the speedometer increases. Okay, it shows the speed at that particular instant only. Okay, and then next, what do I mean by uniform speed? Uniform speed means that the speed is always the same. Okay, in physics, we use the word uniform and constant, same meaning. Uniform means constant, constant means uniform. Okay, so it means that the speed is always the same. Means that the change in distance for every second is the same. So you can take a look at this table. As the time increases by 1 second, the change in distance is all. At time 0, the distance is 0. At time 1 second, it travels 10 meters. At time 2 seconds, it travels another 10 meters, becomes 20 meters. And at time 3 seconds, another 10 meters, it travels 30 meters. So every 1 second, constant speed. Next, okay, the difference between speed and velocity is that speed is a scalar quantity because I use distance divided by time. Since distance is a scalar, speed will also be a scalar. But for velocity, velocity is a vector quantity because I'm just going to replace the distance with displacement. Okay, so velocity is defined as the displacement per unit time, or I can write it as the rate of change. Rate of change is the same which just now I say, it means divided by time, or rate of change of displacement, or I can say it as the change in displacement per unit time. Per unit means divided. Okay, so again, the SI unit doesn't change. It's still meters because displacement is also in meters and then meters per second. So the formula for velocity will be displacement over time. So I just take the distance out and replace it by displacement. So velocity is a vector because displacement is a vector. Okay, then the same average velocity means total displacement divided by total time taken. Okay, so since velocity is a vector, it has both magnitude and direction. And so how is speed and velocity different? Okay, we say that the velocity will change as long as either the speed changes or the direction changes. So you take a look at the following example. You have a vehicle moving along east, and then after that it moves along north. So it goes by the blue arrow and then the red arrow. Okay, for both of them, the speed is 5 meters per second. We say that this car has a constant speed throughout its entire motion. So I move 5 meters per second, means every second this car have traveled 5 meters. Okay, along the east, and then after that along the north. Okay, we say that it has a constant speed, but it doesn't have a constant velocity because velocity is a vector, direction matters. The direction of the car change at this right angle turn. Is initially moving along the east and now is moving along the north. So when the direction change, we say that the velocity changed, even though the speed remains constant. So although I am still covering 5 meters every second, but my velocity changed because my direction changed. So my velocity, remember velocity is a vector, so the direction must be stated. So when I say the velocity at the start is 5 meters per second due east, and then after that the velocity changes because now it is still 5 meters per second, but it is due north. Okay, next word example, you can take a look at this. You may pause the video to think for a short while. Okay, now I'm going to go through. A car takes half an hour to travel 7 kilometers from A to B. What is its average speed? So I want average speed. Give me the formula. Average speed is total distance over total time taken. So I have traveled through a distance of 7 kilometers, which is this blue line. Okay, and then I move from A to B. So that is the total distance. Speed is a scalar quantity, so it's distance over time. So the total distance is 7 kilometers over the total time. The total time is half an hour, so it's 0.5 hours. So I will get 14 kilometers per hour. But when I talk about velocity, okay, the formula goes to average velocity is total displacement over total time. The total displacement will not be 7 kilometers. It's only the distance between A to B in a straight line. So it is only 5 kilometers. So it's 5 kilometers divided by total time, which is half an hour. I get 10 kilometers per hour. So there is a difference between speed and velocity. Okay, because one uses distance, one uses displacement. Okay, the next word example. The same car now I take another half an hour. So total I take 1 hour. Just now half an hour to move from A to B. And then now I travel back along the same path, the blue path, another 7 kilometers. Back to A again, I take another half an hour. So what is now the new average speed? Again, speed will give me the formula first, total distance over total time. So now the total distance is 7 plus another 7. Okay, I travel 7 kilometers forward and 7 kilometers backwards. So I travel a total of 14 kilometers, okay, in 1 hour. So my new average speed will be 14 kilometers per hour. But now my new average velocity will be the total displacement over the total time. My displacement, I go from A to B is 5. I go from B back to A is -5 because it's moving in the opposite direction. Or my displacement is 0 because I start at A, I end at A. My starting and ending point is the same. So my displacement traveled will be 0. Okay, so 0 divided by 1 will be 0 kilometers per hour. That's my average velocity because my displacement is 0. Okay, more word examples. The same car now again takes another 15 minutes to reach point C. What is its average velocity? So give me the formula again. Average velocity means total displacement over total time. So now displacement is just from the starting point to the ending point. So my displacement now is -2 kilometers. That's my total displacement. Okay, -2 over the total time, I'll take 1 hour 15 minutes. Okay, which is 1 hour and 1/4. 1 and 1/4 hour, which is 1.25 hours. Okay, so now my velocity is negative -1.6. Negative simply means, again, the car is moving in the opposite direction because velocity is a vector that's positive and negative again. Once velocity becomes negative, means I am moving in the opposite direction. My final one is my car is moving in the opposite direction at this particular instant. Okay, so just take note, velocity can be negative because it's a vector, but speed cannot be negative because speed is a scalar. Okay, so let's do a comparison. Okay, speed is the distance per unit time. Velocity is the displacement per unit time. Speed is a scalar quantity because I use distance. Velocity is a vector quantity because I use displacement. Okay, both of them have the same SI units, which is meters per second. Okay, in formula, speed is distance divided by time, velocity is displacement divided by time. Okay, so velocity, there is positive and negative, but for speed, there is no negative speed. Okay, so this page also sum up the formulas that you need to know as well as their definition. Okay, speed is distance divided by time. Average speed is total distance over total time. Velocity is displacement over time. Average velocity is total displacement over total time. For definitions, they often like test in O level, so please spend time to memorize them. Okay, so I already say per unit is the same meaning as divide. So you can define speed as distance traveled per unit time, or you can say it as the rate of change of distance. Average speed, total distance traveled per unit time. For velocity is the displacement traveled per unit time or the rate of change of displacement. And then the average velocity will be total displacement per unit time. Okay, let's move on into the last part for 2.1, which is acceleration. Acceleration is something very new to you. Okay, acceleration is actually defined as the rate of change of velocity. It simply measures how much does the velocity change in every 1 second. And just take note that I am using velocity, which is a vector quantity. So acceleration will also be a vector quantity because I'm using velocity. It's not the rate of change of speed, it's the rate of change of velocity. Okay, so direction does matter because it's a vector quantity. So when will I have acceleration? Whenever I have a change in velocity, I will have a change in acceleration. So when will the velocity change? It's either there's a change in magnitude. Okay, so for example, when the velocity changes from 20 to 30, there's a change in magnitude of the velocity, there's an acceleration. Or I can have the same magnitude, but when I change in direction, when there's a change in direction, there's a change, the speed is constant, 20, 20, but there's a change in direction, there will be change in velocity. So when there's a change in velocity, there will be an acceleration. Or it can be both. I change direction and also change the magnitude. Okay, so the SI unit for acceleration is also something new to you, is meters per second square, or we can represent it as ms minus 2. Okay, it's the change in velocity, which is meter per seconds per seconds. Okay, is the change in velocity per unit time. So meters per second divided by seconds, you get meters per second square. Okay, so the formula for acceleration, please memorize it. It is used very often throughout a lot of chapters. So acceleration is defined as the change in velocity per time taken. Okay, but we don't usually write out in words. We use symbols to represent it. So acceleration is represented by A, okay, equals to the change in speed or change in velocity, which is final velocity, minus the initial, which is the starting velocity, over the time taken. Okay, remember, everything when you sub into the formula, it must be in SI unit. So the time must be in seconds, the speed or the velocity must be in meters per seconds. Okay, if it's not, you have to change it first. Okay, so acceleration is a vector quantity. So later on, we will look into what examples on how to apply this formula of final speed minus initial speed over time. Okay, so again, because acceleration is a vector quantity, there is both positive and negative. Okay, but negative doesn't mean opposite direction for acceleration. Okay, we say that an object having an acceleration is when the object is moving faster and faster and faster. Okay, that's why in car we say that you step on the accelerator. When you step on the accelerator, your car moves faster and faster and faster. So acceleration means moving faster and faster and faster. So it means that where the velocity is increasing. Okay, so-called is a positive acceleration. But acceleration can also be negative because it means because it's a vector. Okay, but negative acceleration, it simply means that in the opposite way. It means that the velocity decreases. Whenever the object is moving slower and slower and slower, we don't say that it is accelerating. We say that it is decelerating. Okay, the term used is decelerating. You will see decelerating more often in the newer books, but in very old books, sometimes they refer it to as the retardation. Retardation. Okay, so simply means moving faster and faster means accelerate. Moving slower and slower means decelerate, or in older books, it means retardation. Okay, or sometimes we refer it as negative acceleration. Negative acceleration means slowing down. Okay, so let's take a look at what does it mean. So for example, again, the word uniform means constant. Constant acceleration means that the change in speed every 1 second is the same. So if you take a look at this table, for every 1 second, the velocity changes by 20 plus 20 in the first part. It means that the object is moving faster and faster and faster. At 1 second, it's moving at 20 meters per second. 2 seconds, is moving at 40, then 60, then 80, then 100 meters per second. So if the object is moving faster and faster, we say that it is accelerating. We say that it has a constant acceleration of 20 meters per second square. Okay, therefore the acceleration is 20 meters per second square for the first part. Okay, over here. Okay, but then if you see the second column over here, or the third column over here, as the time progresses, the speed decreases or the velocity decreases. It decreases from 100 all the way to 0. It is slowing down, and it is slowing down by 20 every second. So that we say that it has an acceleration of minus 20 meters per second square. The minus simply means that it's slowing down. Okay, we say that it has a negative acceleration, or we can say that the deceleration is 20. Or right down here, you can see that the acceleration is minus 20, or we can say that the deceleration is 20, because the word deceleration simply already consider the minus sign. Deceleration and acceleration are opposite. So acceleration of minus 20 means deceleration of 20. Okay, so I give you more examples over here. What does it mean? Okay, you can use interchangeably. If acceleration is 5, okay, then we say deceleration okay, I just put D as acceleration. Deceleration will be minus 5. If the acceleration is minus 5, then the deceleration will be 5. So acceleration and deceleration are opposite. So you just stay around with the plus and the minus sign. Okay. Next, then non-uniform acceleration is when the speed doesn't change constantly. So you can see at 1 second, the velocity is 10, and then 2 seconds is 40, and then 3 seconds is 60, and then 5 seconds is 50. So the velocity doesn't change constantly. We say that it has a non-uniform acceleration. But we'll talk about non-uniform acceleration more in depth later on when we take a look at the graphs. Okay, so let's take a look at work examples to see how we apply the formula of A equals to V minus U over T. So you can read this. The velocity of a car changes from 15 to 10 in 1.2 seconds. Determine its acceleration. The first step, you must be able to identify that the velocity actually decreases from 15 to 10. It means that the car is slowing down. If I am slowing down, my acceleration will be negative because I am slowing down. Okay, I am not accelerating. Accelerating means moving faster and faster. I am actually decelerating. I'm moving slower and slower from 15 to 10. But I did not ask for deceleration. Even if the question asks for deceleration, there is no formula for deceleration. There is only a formula for acceleration. So I always need to use the formula for acceleration. So you give me the formula. Acceleration is final velocity minus initial velocity over time taken. So the final velocity of the car, that means the ending velocity of the car, okay, it changes from 15 is my starting to 10. 10 is my final velocity. So I get 10 minus my starting velocity, which is initial velocity, is 15. 10 minus 15 divided by the time taken is 1.2 seconds. So if I have to type in my calculator, I get minus 4.2 meters per second squared. Okay, is the SI unit for acceleration. Okay, it's negative because the car is slowing down. So I'm having an acceleration of minus 4.2. I am slowing down. But if the question asks for deceleration, you still have to use this formula. Acceleration is final velocity minus initial velocity over time. Then you just add in one more statement. The deceleration will be 4.2. I just remove the negative. Okay, so depending on whether the question asks for acceleration or deceleration. Okay, but acceleration will be negative because it's slowing down. Okay, the next example. Okay, a stationary truck accelerates with an acceleration of 1 meters per second for 15 seconds. Determine the final velocity. Again, I give you the acceleration. I give you the time, 15 seconds. Determine the final velocity. Okay, just take note that there is this word stationary over here. So it means that my initial velocity is 0. I am not moving. It's a stationary truck. The initial starting velocity will be 0. Okay, so I'm going to sub it into my formula. So my formula will be A equals to V minus U over T. Okay, so I'm going to sub it in. My acceleration will be 1. Then I don't know what is my final velocity. So it's still V minus my initial velocity, which is 0 because it's a stationary truck, over a time of 15 seconds. So if I were to work out and make V my subject, okay, my final velocity, my subject, my final velocity is 15 meters per second. Okay. Okay, then next, you may scan this QR code and then to work on what is positive acceleration and what is negative acceleration or deceleration. Okay, and then I still have more QR codes and that you can scan to work on to practice on it. Okay, that's the end for the first part.